FR4 is the base material for the inner layers of a multi-layer PCB. FR4 is a composite material consisting of woven fiberglass cloth and an epoxy resin binder, which is pressed together with copper foil. The base material for inner layers is between 0.06 mm and 1.5 mm thick. Generally, the inner layer base copper thickness is the same as the inner layer final copper thickness. The base material is cleaned and a photosensitive laminate is applied. Next, an image from a photo tool is transferred through exposure and the future conductive pattern is generated, the layout. The following 3 production steps all take place in one system. In the first step, the layout generated by the exposure process is developed by means of a chemical process and the unexposed parts of the laminate are removed. In the next step, the unprotected copper is etched away to create the conductive pattern that was imaged. Finally, the polymerized photolaminate is removed. These 3 steps are called developing, etching, and resist stripping. Before the layup of the subsequent materials is carried out, an automated optical inspection takes place. The surface is then oxidized. The purpose of this oxidation is to achieve a better bond between the inner layer and what is known as the prepreg. The prepreg is needed in order to bond the following layers together. Next, the material for pressing the multilayer is laid into place. The following structure can be seen: outer layers, prepreg, core with layout, prepreg, outer layers. The materials are pressed together with a pressure of about 15 bar at a temperature of approximately 185 degrees Celsius. After the pressing process, the panel edge is trimmed to produce a clean contour, and the PCB is measured to correct any deviations caused by pressure or temperature. Once these steps have been completed, holes are drilled to connect the individual layers. There are various types of holes, such as vias to connect the individual layers, or component holes that are needed for the subsequent population of the PCB. The next step after the drilling is the through-hole plating process. In this process, holes are cleaned, activated, and given a thin copper coating to create a vertical electrical connection between the conductive layers. The outer layers are then processed. Firstly, a laminate is applied. This lamination process is similar to the inner layer process. In the photopositive method, the areas that are not needed for the PCB layout are exposed. The aim is to expose the areas that will subsequently be plated. In the following step, the unexposed laminate is removed. Then, at the exposed copper areas, the copper coating is plated up and the final copper thickness is attained. A layer of tin is applied to protect this copper layer for the next 3 processes. The first of these processes is photoresist stripping, in which the polymerized photoresist is removed. Then the areas not covered with tin are removed in an alkaline etching process. Finally, the protective tin coating is removed. At this point, the circuit board is already electronically functional. Now, the protective and finishing processes are carried out. The first step of these finishing processes is to apply a photosensitive layer of solder resist. This protects the PCB against corrosion and mechanical damage, and during soldering, it prevents solder from being applied to the areas covered with solder resist on the PCB. It also improves the electrical properties and dielectric strength. Like in the previous photo processes, the desired surfaces are protected against exposure. In the subsequent development process, the solderable area, solderable pads, and the component holes are uncovered. Then, a solderable surface finish is applied. This could be, for example, immersion silver, immersion tin, electroless nickel immersion gold, HAL, or lead-free HAL. Temporary solder resists or protective tapes can be applied depending on the requirements of the following solder processes. One of the last steps is the application of the desired annotation via screen printing. The final mechanical processing ensures that the multilayer gets its final shape. Here, this is done by milling. Before the multilayer is shipped out, we carry out electrical, optical, and dimensional inspections of the PCB.